Hi all, I am Arundhathi. Today I am here to say about special theory of relativity. Okay, before that I will ask you a question. We already have Galilean transformations and all, no? That connects, that relates between two frames. So why we need a theory like special theory of relativity for that? I think that Galilean transformation is not complete or it needs some modifications. So, Galilean transformation does not work well in Maxwell's equation of electromagnetism, and also the Michelson-Morley experiment, there is something. So, I will explain. Before there is the history behind that. Okay, scientists at that time, they know about some waves like sound waves. So that sound waves needs a medium to travel. So they know that light is also a wave. So they thought the light also needs a medium to travel, and they called that one as ether. It's not. They actually don't know whether there is a medium or not. They assumed like sound is a wave and it needs a medium to travel. So as light is also a wave, so it may also need a medium to travel. So they called it as ether. So like that Michelson-Morley experiment, no, you may if you watch the previous videos, you may know that. So in that Michelson-Morley experiment, it was done to find the presence of ether, to find that medium. But actually they didn't find it, but they found another one, like speed of light is same everywhere. Like even if they change the direction, it won't change. The speed of light is constant, it's not changing. So it's a confusion for the scientists at that time. At that time, at this time, Albert Einstein came with this special theory of relativity in 1905. Okay, so the special theory of relativity, it has two postulates. One is the laws of physics is same in all inertial frame. The second one is the speed of light is same in all inertial frame. So before going into that special theory of relativity, I will tell you what is inertial frame. So you know, by Newton's first law of motion, an object will continue to be in its state of rest or in uniform motion unless an unbalanced force is applied on it. Which means if I am an object, assume I am an object and I will continue, if I am in rest, I will continue in that state of rest, or if I am in motion, then I will continue that motion. If there is not an unbalanced force is applied on me, then I will continue in my whatever state I am, I will continue in that state only. So this was about an object. So here we are considering about frame. Like if I am an object, consider I am an object, and the place where I am in. Like if I am in train, I am traveling in a train. Okay, so it is moving with a uniform velocity. So that train is a frame, like wherever the object is situated, it is a frame. So that train is a frame. Now here I am in a classroom, so this class is a frame for me. Okay, understood. So coming back to the special theory of relativity, that postulate all laws of physics are same in all inertial frame. The laws of physics are same in all inertial frames, which means you know the laws, like whatever you studied till now. These laws all are applicable in this inertial frame, like some laws like reflection, refraction, everything, no? Like if it is in a special in an inertial frame, then we shouldn't apply like different laws for each and every frame. It can be applied to everything. That is this first law. And the second one is speed of light is same in all inertial frame. Okay, before that I will tell you an example. Okay, if I am riding a bike, okay, and like if I am traveling in riding at 10, my speed is 100, then it seems that the outside objects, like whether the trees, shops, everything, whatever in the outside, it will be for me it will be like moving backwards, no? And if if my speed is 100, then the velocity of that object moving backwards will be 100. Like whatever the speed of my bike, it will be same. Like if I am moving at 20, that speed, my speed is 20, then the object seems to be moving slowly. Okay, so like whatever, like if I am moving in some speed, then the objects outside will also be in that speed in opposite direction to me. Okay, but in the second postulate, by that second postulate, it's not like that. Like the speed of light is same. Like if I am traveling at 100 speed, my speed is 100, then also the speed of light is same. Like if it is k, then it will be k only. And if I reduce my speed to 20, then also the speed of light will be 20. Sorry, the speed of light will be k. K is some constant I am saying, or like if it is 3 into 10 raised to 8, then it will be 3 into 10 raised to 8 only. Like if my speed, the speed of my bike will be 100, it won't be like k plus 100 or k minus 100, it won't be like that. Or if it is 20, it won't be like that, k minus 20 or something, or k plus 20, it won't be like that. Okay, that is special theory of relativity, that second postulate. It will be same in every in all inertial frame. Okay, like before dealing with this special theory of relativity, I'll tell you one thing. Just this special theory of relativity, okay, it is a part of our common sense. Like throw your common sense away. That's what I'll say. Like what's common sense? Like some things which we are used to in our day-to-day life or daily life is our common sense, okay. But whatever I am saying in this special theory of relativity, it will not be, we may not be experienced of. Like for example, I'll tell you one situation. Like in the earlier times, okay, people at that time they thought that the sun revolves around the earth, right? But now we know that it's not the sun, it's the earth and other planets are revolving around the sun. That's our common sense now. But earlier people thought their common sense was that one. So like if we are not used to something, then it will be difficult for us to digest. So same as here, just these things, whatever we are saying in special theory of relativity, we may not be experienced of. So it is difficult for us to digest, but it is what actually the nature works of. Like nature, like if it's not because I am saying this one, or it's not because Einstein proved this, it's not because of that. It's if some object is traveling close to the speed of light, it will be like this only, that nature works like this. That is special theory, that is this one, is these two postulates. And I already said the speed, and we know that speed, distance and time, these equations like speed equal distance traveled by time taken, no, that equation. So by that equation, wait, okay, speed equal distance traveled by time taken. Like if here I am saying the speed is same, so there should be some modification made by distance and time. Okay, like otherwise it will be like both these, like if speed is something, then speed is something like for that distance covered divided by time taken. So if the speed is constant, then that distance and time should make some adjustments. Okay, that are consequences of this special theory of relativity. That things we will tell in detail in our next videos. Like if the time is making some adjustment, we will say it is time dilation. And if the distance is making some adjustments, then we say it is length contraction. That we will go through it in detail in our next videos. So, like I will conclude this video we talked about that special theory of relativity, that Michelson-Morley experiment, then special theory of relativity, that two postulates, and then the consequences, and rest all we will tell in detail about in our next videos. Till then, bye. Thank you.